Good evening to the Dr. Swada. Now, our group J will present the distributed system simulation for our group project. Okay. This our group member for our group. There are 4 members. And next to a project overview, we design a system that can simulate the distributed process using trace naming resolution with dictionaries and a hierarchical case and a consistency model. Okay, we use the thread pool executor to simulate the concurrent service execution. So when the service 1 and service 2 are submit to a pool to run in parallel, so it will be advancing a distributed service running independently. And later we will simulate the migration by calling the executor. So shows how a service can be dynamically relocated and continuing in its task in a new thread. And the key concept in this process model that when the service run concurrently via threads and the state updates simulate a real distributed process and the migration transfers stack across thread pools, and this shows how the basic distributed processing concurrent and dynamic service movement.
So we will see the naming systems. I am the naming architects. My name is Christopher Woons. The titles of naming models is about the thread and structures namings. For the thread namings, we use mat strings, Swiss thread maps, new hash maps, and thread maps dot puts S1s and 192.168.0.0.1 8080. Such names will use the DNS styles. Register service 1.university.edu 192.168.1.10 to 5000, as well as service 1.university.edu. For the outpost, naming register service 1.university.edu will refer to the 192.168.1.10.5000. Naming resource service 1.university.edu will refer to the 192.168.1.10 to 5000. In short, the thread naming is fast for small systems, but the shortest naming supports hierarchies and scalabilities. That's all for me. I will pass the address to next visitors.
For the replication and consistency model, so now let's explore how distributed systems maintain consistency across multiple replicas. First is sequential consistency. All nodes get updates in same order. For example, sequential consistency 5 mean every nodes get the value 5 one after another in the same order. It is very safe and consistent, but a bit slower because it waits for all nodes. And next is eventual consistency. This one is faster but less strict. For example, equential consistency 10 send send the value tens to all nodes, but not the same time. Maybe node 1 is offline, so nodes 2 and node 3 updates. Later on, node 1 will catch up. It's okay for the nodes are different for a while. They will match eventually. And last is client-centric consistency. This one focus on what users see. Example, client-centric consistency, client X 15 mean kernel X write value 15 to nodes 1. When kernel X check later, it will see 15. but maybe other user may see the old value like 10. It's very fast and good when user just want to see their own update quickly. So we can see that sequential is the fastest and same order, but a bit slow. Eventual is fast, but not always in synchronized. Client-centric is fast for user, but other might see old data. So different models are used for different goals like safety, speed, or user experience.
A very good evening to our lecturer, Dr. Shuhada, and my fellow friends. Today, I'd like to present my role as results and takeaway analyst. So, first of all, based on the coding output that we ran and the result that we get for report 2, replica state, as you can see, node 1, node 2, node 3, state 15, 10, 10, and status icon 15 is the latest value for node 1, and while node 2 and node 3 are syncing. As you can see here, this is the output that we got for client when client X writes 15 to node 1 based on the client centric consistency. So this one is our metrics table. As you can see, the value that we have got as output is 5, 10, and 15, and the latency is 1 millisecond for 5 and stay rate 0, 3514 millisecond for the value 10 and stay rate 0, and for the value 15, 1 millisecond and 2 for the stay rates. As you can see here, I've marked trade-off with this symbol to indicate the trade-off between speed and consistency. So for the stay rate 2, yeah, this is the trade-off. And for the symbol green, it's lower latency. As you can see, this is the output that we got for our metrics, latency and sale rates. That's all. Thank you.